Okay, so the first video is going over expressing these quantities as standard base units. So we'll start off with force. Okay, so here we have force. We know that we measure force in newtons. There's a symbol for newtons. We know force from Newton's second law. Force is equal to mass times by acceleration. So force, which is newtons, is the same as mass, which is in kilograms, times by acceleration, which is meters per second squared. Now, just here above here, I've written all the standard units that I'm going to refer to: kilograms, meters, seconds, amps, candles, Kelvin, and moles. So let's have a look at the first one. So newtons, kilograms, meters per second squared. Now, it's kilograms multiplied by meters per second squared. That's standard base unit, that's a standard base unit, and that's also a standard base unit. So I've expanded out newtons in terms of kilograms, meters per second squared. So here we've got kilograms, meters, and seconds, and that's our base unit for newtons. So newtons expressed as a base unit is kilograms, meters, seconds to the minus 2. Now, next we've got work done. So we know that energy or work is measured in joules. Symbol for joules is capital J. We know that work done is equal to force times distance. So work done, joules is a unit, force we know newtons is a unit, and distance we know meters is a unit. Okay, so we're going to expand out newtons because that's not a standard unit, as you can see across the top, but we have expanded out newtons previously, and we know that newtons is kilograms meters to the second to the minus 2. So we're going to write down kilograms meters per second to the minus 2 here, and we're going to multiply by meters. That is also a base unit for distance. So therefore, meters to the power of 1 here, meters to the power of 1 here. Add the indices when we multiply, and we end up with kilograms meters squared seconds to the minus 2 for joules. So joules expressed as a standard base unit is kilograms meters squared seconds to the minus 2. Next, power. Power, we measure power in watts. Symbol is capital W. We know that power is the energy transfer divided by the time taken. In symbols is written like that, P equals E over T. We know power is measured in watts, so we can express this formula in terms of units. So watts equals energy is joules and divided by time, which is in seconds. So the watt is equivalent to 1 joule per second. Now expressed as in indices form, so it's joules times by seconds at the bottom, so it's seconds to the minus 1. And now we know joules already is, from our previous expansion, kilograms meters squared seconds to the minus 2. And we know that is our standard base representation. So we're just going to replace joules with kilograms meters squared seconds to the minus 2 as here, and then multiply by seconds to the minus 1, which is there, and that's minus 2 times by minus 1 for seconds, and we bring it together. So 1 watt can be expressed as kilogram meters squared second to the minus 3. That is in standard base representation, because every unit here is represented in the 7 base units. So we've got kilograms, meters, and seconds. So we don't need to expand out further, we just leave it there. Okay, next, frequency is expressed in hertz. Unit symbol hertz, capital HZ. We know that the definition of frequency is a number of cycles every second as a formula. That is F equals 1 over T, where T is the time period and F is the frequency. So we know frequency is measured in hertz, as we've just discussed. 1 over time period, time we know is measured in seconds, so 1 over seconds, so that's a base unit already, so that's second to the minus 1. So hertz is expressed in base units as seconds to the minus 1. Okay, next. So we're going to look at charge, and we know charge is measured in coulombs and the unit is capital C. We know that charge is equal to current multiplied by time. So we know charge is measured in coulombs, so we put capital C here for coulombs. We know current is measured in amps, and we know that time is measured in seconds. Now, so let's check if current and seconds are base units. So let's go up there. Current, yep, it's amps, so that's a base unit. Seconds, that's a base unit. No need to further expand. Okay, so here we've got current times time, amps times seconds. So coulombs charge is the same as amp seconds. Okay, expressed in standard base units. So coulomb in base units is amp seconds. Voltage, we know, is measured in volts, or potential difference. Capital V is the unit for volts. So potential difference, i.e. voltage, is equal to work done, or the energy transferred per unit charge. So work done divided by charge is expressed as a simple formula. The potential difference V is equal to E, energy transferred, over charge. So we know potential difference or voltage is measured in volts, so volt. We know work done, energy transferred, is in joules, J, and divided by charge, which is coulombs. Now we've just worked out the standard base units for coulombs is amp seconds. So where we see coulombs, we're just going to write amp seconds. We've done that before. Okay, so that's your standard base unit there. We know joules. Earlier on, we found the base unit for joules is kilogram meters squared seconds to the minus 2. So we're going to put that there at the top in place of joules. And then we're going to bring it all together. We know that amp seconds is at the bottom of division. So that's amps to the minus 1, seconds to the minus 1. And then there is seconds to the minus 2 and seconds to the minus 1. That ends up as seconds to the minus 3. So that's kilograms meters squared seconds to the minus 3, amps to the minus 1. Next, resistance, measured in ohms, and resistance, that's the omega sign for the unit. So resistance, we know, is voltage over current, so V over I. We know that the voltage is measured in volts, current in amps. We know current is already standard base unit for amps, so that's don't need to change that. Volts, we've just done that previously. We know volts is kilograms meters squared second to the minus 3, amps to the minus 1, so we put it in place of that there. And then we bring it all together, so that's kilogram, because it's amps at the bottom, that becomes amps to the minus 1 here. So that's kilograms meters squared seconds to the minus 3, amps to the minus 1 times by amps to the minus 1. So bring that together, add the powers, and that ends up as minus 2. So kilograms meters squared seconds to the minus 3, a to the minus 2. And the reason why we add powers, because it's multiply. Okay, and that is the standard base representation of the ohm. So 1 ohm is in base units is 1 kilogram meter squared seconds to the minus 3, amps to the minus 2. Pressure measured in pascals, the unit is expressed as PA. Pressure is, we know, force divided by area. So the pressure Pascal in pascals is force, which is newtons, divided by area, which is meters squared. We know newtons from earlier on is kilograms meters per second squared, and divide by meter squared, put it in indices form, and that's kilograms meters to the power of 1, and then we've got meters to the minus 2, that ends up with meters to the minus 1. When we add the powers, and then the seconds to the minus 1 stays there, so we got a unit power as pressure is equivalent in base units as kilograms meters to the minus 1 seconds to the minus 2. So 1 Pascal is the same as 1 kilogram meters to the minus 1 seconds to the minus 2. And if you look at every answer in base unit representation is in the form of these 7. So it will be a mixture of these 7 base units. So when we end up with an answer, the answer should only have kilograms, meters, seconds, amps, candela, Kelvin, or moles. So if you see any of those, you don't need to expand any further. Okay, right. So that's done.